Good evening, everybody. So how was your test 3? Question was hard or okay? Okay, like test 3 in your final, you will not be given the unlike your test 2 or previous test. You see that we gave the format of like push method or pop method. You are asked to write 2 lines or 3 lines. But in future, you have to understand the entire signature, including the signature of a method. Okay, so basically, we are enforcing you to practice. If you practice, then it should be good. Okay. But if you try to memorize code, then it should not be good. Okay, but okay, so let us see our schedule first. So I think we have one more topic we want to cover in our next lecture, binary search tree. And after the Thanksgiving break, we will be able to review. We will have 1 week, that means 2 lectures we will review. Or if you think that I missed something important, then please send me an email that this is the thing that we missed, then I will cover. Okay, I was grading the test. I started grading, but the reference parameter questions, okay, there was only, although for C#, I'm very satisfied that many of you did mistake. Okay, so although it is only for C#, but I asked everybody to understand this, and maybe I discussed this in lecture with some live program. So if you go to my Replit account and reference parameter example 1, I just want to review one more time so that in future, if you face this kind of problem, you can do it correctly. So let us understand let us recall what a reference variable or reference parameter does. Okay, like I gave a very silly example, but I thought that example should be your lifelong learning, but that did not happen. Sorry, I gave the example that I learned that way. I remember that. So your normal variable is a transient variable. Normal parameters are transient. So as long as your program goes away or your function exits, then the effect of the normal variable like x over here will go away. Okay, but your reference, if you declare a variable as a reference with ref keyword in C#, so that means a reference parameter. We assign this. Okay, so that means I told you that your normal variable is your guest, that you would not allow your guest to change you will invite your guest. Okay, you will entertain him or her, and then give him some food or drink, and then say goodbye. But if you have some special guest, and if he tells you, okay, that you need to change your bedroom, you need to reshuffle your bedroom, or resize, or you need to change these, or you need to change this, and if he or she has that power that you have to follow, then that is the reference parameter. So what does a reference parameter do? A reference parameter can change the value permanently. Okay, so here I have 2 variables here for this program, 2 parameters, x and y. X is traditional variable, okay, and y is reference. Okay, here my function definition, do it function definition, okay, and it should match this one. So it has integer a is a normal variable. Whatever value I say a, b, c, that doesn't matter, but we need to see type. A is normal variable argument and b is reference argument, reference parameter. Okay, so what actually this variable it does when this method is called. So at this point this method is called, right? Line number 7. Whatever value it gets for as a reference, it changes that value permanently. Okay, so how that changes happen? Here, so what we are doing, whatever parameter it gets, a, that increases by 12, and whatever it parameters is gets value, that decreases by 42, right? So when you call do it method with x is my 55, so it will increase 55 plus by 42 12, so 55 plus 12 is 67, right? So at this point my x will be, we are calling this method here at this point, so this line will be printed first. So the top line will be 67 and then negative 27, and then bottom line is 55, negative 27, and then 94. Yeah, if you so randomly change some values and then run this program, then you should understand this. In your test it was like this, ref, both are ref maybe. Okay, so then it would be here 67 here would be 67, 55 plus 12 equal to 67. Okay, so let us go about parallel processing. So in our last lecture I discussed something about parallel processing, but we discussed only mainly for Java. I have something more to discuss with C#. We discuss more law, Moore's prediction that every 10 years the number of transistors will be double. That means he predicted that the memory's capacity and also the processor speed will be increased. So at that time, maybe about 70 years ago, he predicted that the trend would last then 50 years, but still it is continuing. That trend, I don't know where it will be stopping. So fast memory's capacity and speeds are increasing. Okay, so the last two slides we do have here, the last two slides are related to C#. Okay, we know that C# in Java and C# and Python, these languages have for each loop control statement, and also C# is parallel for. Okay, so the format of parallel for is that we will use parallel dot for. This for if is in uppercase in C#. Okay, this is a method actually. So then we will put the start index and we will start index value actually, start index value, and then n index value, okay, and the current index, that is actually it is called index, okay, and we use this operator and then do some words. That means with current index we can do something, we can print index or increase index, whatever do, and this, all of this is a single statement. So you will see, when you see code, that it will at the end you will see semicolon. So like this, let us see an example. Maybe with an example it should be easy to understand. If you go to my Replit account, you see that I have an I created a program over here, parallel, for example 1 C#. Okay, this parallel for is defined within the Java thread class. So this is why we need to include thread.task. Maybe you can include thread.start as well, as it should work. Okay, and here is this is a simple program. So, okay, so the parallel.for, this is my starting index. For this is my index variable I, okay, and this is my starting index. Start with 1, and the ending index is 10. Actually 10 is not included, 1 is included but 10 is excluded. If you know Python range method does not include the last index, so like this, like in Python similar to, so 10 will not be included, but that means it will not never print 10. It will be printing the number 1 to 9 actually, and every time it is increasing by 1, okay, and so this is only one statement. You see the semicolon is here at the end of this semicolon. This is one statement. So what do we think that what will be printed for if we execute this statement? Yeah, unlike the traditional for loop, if it was a traditional for loop, then it would print the numbers from maybe 1 to 10, right? You'll be printing the number 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this way in regular format. But this does not work that way. So it will be printing, it will be selecting a number randomly, the range from 1 to 9, between 1 to 9, and then number, it will print 10 numbers, it's okay, but it will select the numbers from 1 to 9 and it will be printing in random order. I'm sorry, it needs this task. It's not working with task. Sometimes C++ works with this task, with star. Okay, so if you see this program 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers are printed? No, 10 numbers. 1, 2, 3, 4. This is 4, right? And this is 5. Okay, 5. Is it the last one? Oh, 9 numbers, okay? Okay, the numbers range from 1 to 9. But the number will be printing, the number will be selected randomly. So if I run this program another time, okay, remember, just for a second, remember that the sequence 1, 2, 4, 6, 8. So there is no sequence. 3 is gone on the back, right? So if we rerun this program again, we will see that a different pattern output. So you got this time 5, 6, 8 in random order, right? Okay, so if you run it again, it will be printing in another order. It will be printing in another orders. But as many times as you print this run this program, you will see that it will be printing numbers between 1 to 9 because 10 is excluded. Okay, and this will be printed in random order to us. That happens actually since multiple threads are being created. Okay, and each of the thread takes one value, one of the I value, and it takes print. So we don't have control right now in this small program of which thread will be. We don't have any thread management system here. So which thread will be called first, then which one next, then which one next. So this is an example, so that we know that C# has this parallel for. So this example is wanted to say that the parallel for. Okay, the parallel for. So there is also another parallel invoke method. That you can schedule a task in several ways, the simplest of which by using parallel invoke method. The following example, it does not give us the, but if you do a Google search you will get example. I did not include, maybe. Okay, this is parallel for each works for object. I believe if you take advanced level course, then you will learn this. But if you, I think you don't need this much. But for your lab assignments, okay, there are some assignments related to parallel processing, right? Okay, I have added some sample programs on my GitHub account, on my not my GitHub account, on my Replit account. So if that parallel array example, okay, I was testing actually parallel processing assignment, maybe the 7B. So if you go to these programs and if you practice this program, then it should be good for your lab, the last lab assignment. Okay, I have also some program. It should have some program here. This one, parallel array example with Java. So I have some examples. So you can copy this program and try yourself. If you understand, then you should be good for your assignment. What else? Okay. The last one, the slide, for the parallel processing slide. Actually, this is for advanced parallel processing. Okay. So this is the presentation I usually give during my job interview. I gave this presentation here last year, so they included this in their course content. Okay, so parallel processing is included with Java since is version 1, the very first version. Okay. So from the very first version, we know the parallel processing concept is there. Parallel processing concept is that there are multiple processors, and multiple processors will process. Processors means CPUs. Okay, and then multiple processors will process multiple programs or procedures or segments of a program, multiple segments. And then if there are multiple processors, if they process this program parallelly, then execution time will be faster. So the problem is that whatever program we discuss for our demo program or in our lecture, very small program, that takes only very few milliseconds, right, to execute it. So we do not realize how much time it takes to execute the program. Okay, but if we use some system clock to use the runtime, start time and end time, get start time and end time, and if we find the difference between end time and start time, then we can get how much time it takes to execute the program, right? So there are the tools. So in this program actually we will see that this ForkJoinPool, how it is efficient and how it works. The name of the ForkJoinPool is self-explained. Fork means splitting a task and joining the result together. So the ForkJoinPool is the latest technology that has been included in Java. Before that, Java, since its first version, it has thread. So we already discussed thread programming, how to create a thread by extending the thread class or by implementing the runnable interface, right? There are two ways, thread, and then we also discuss how to use parallel programming. So, and then later, since Java 5th version 5, actually version 5, they included executor service. Executor service is a class that had included a few years ago, like 7, 8 years ago. So that was another technology to perform parallel processing. But recently with Java 1.7, Java 1.7 came a few years, 5-6 years. So they included ForkJoinPool. ForkJoinPool is more likely the executor service, but we are not discussing executor service here in details, but I'm skipping that. So ForkJoinPool is like a technology. Let me okay, here expand the slide. So you will have a task. The task will be splitted into some small subtasks. Okay, then each of the subtasks will be again splitted until it goes to a base case. Like for instance, we know the base case when we go to recursive order for recursive, what is that called? Factorial calculation. We consider 1 or 0 as base, right? Okay, so that means a number is splitted into base. Okay, so when it gets the base or small chunk, then a processor takes that part and quickly execute the result. Quickly execute, and the result are then joined or merged together to get a larger portion of the result. And again, the total result are the chunk result are joined together to get a final result. And this final result is the result of the entire task. Like for instance, if there is a very large array, if you want to add the elements of this array, what you can, instead of adding one person, the entire array, if you have 5 people, and if you say that, okay, let me add my first 100, and you add second 100, okay, and you have third 100, and you had fourth 100, and you add the last 100, and let us add our 5 result, right? So we should get the entire 500, the entire result of an array with 500 elements, right? So they are similar technology. Okay, so a task is splitted into subtasks, and subtasks are executed individually, and finally the subtask result are merged or joined to get the final result, and the final result is distributed or returned. This process is called divide and conquer process. When you take your data structure course, you will learn that technology, divide and conquer method. Divide, execute, and get result. So actually ForkJoinPool uses the divide and conquer fashion. So the task is divided into some small tasks, and the result, each of the result for the small task are merged again to get the final result. So I wish if I could if I extend this, you see that tasks are joined, are divided into some subtasks, and subtask result are joined to get the final result like this. Okay. The algorithm for the divide and conquer method is straightforward. Split a task T, for instance, into some smaller tasks, and for each of these tasks solve the task and wait until all tasks to be completed. When all tasks are completed, join all individual results and finally return the result. The technology is pretty straightforward and simple how to implement ForkJoinPool, ForkJoin technology. So here I am, in order to implement ForkJoinPool, Java uses two methods. Okay, the ForkJoin class, actually it is a ForkJoin. It has two methods. One is fork method, another is join method. The names are self-explanatory. The fork method, okay, splits the task asynchronously, okay, and okay, the join method returns the result of the computation when it is done. So the fork method is used to split the task, and the join method is used to join the result. That is the thing. So for instance, if we want to find the Fibonacci numbers, if we want to find, if we say what is the Fibonacci number, for instance the 10th Fibonacci number or 100th Fibonacci number, 100th. So we know that Fibonacci numbers start from 1, the next number will be 2, right? 1, 1, 2, then 1 plus 2, 3, then 3 plus 2, 5, 5 plus 3, 8, 8 plus 3, 21, like this way, right? Okay. So if we want to get the 5th Fibonacci number, for instance, or the 6th Fibonacci, for instance, 5th Fibonacci number or 4th Fibonacci number. So how the 4th Fibonacci number can be calculated quickly? So we know that 4th Fibonacci number is the sum of 3rd and 2nd Fibonacci numbers, right? The 2nd Fibonacci number is the sum of 1st and 2nd Fibonacci numbers, okay? Or the 3rd Fibonacci number, sorry, the 2nd Fibonacci number is the sum of 0th and 1st Fibonacci number, and the 3rd Fibonacci number is a sum of, let me export this, and the 3rd Fibonacci number is the sum of 1st and 2nd Fibonacci number, and like this, these are the red ovals, these are the base cases. So we already in our program we define this. If 0 or I index equal to 0, then it will return 1 or 0 or something, right? So this is the concept that can be implemented using if ForkJoinPool with Java. Okay. So the concept of implementing ForkJoinPool, so you will have an assignment, like, give attention please. You will have an assignment. In one of the assignment is asked to implement something using ForkJoinPool. Okay, so if you give attention over here, then you should be able to do that over there. Okay, so the first step is to create a ForkJoin object, ForkJoinPool object, whatever object name you give. Okay, and creating an object is straightforward. And second, we will use the object to call the invoke method, and within the invoke method we will pass the task as parameter. Okay, and this process will be mainly executing in recursive fashion. Okay, so here is my program. Actually, this is the program that if you understand this program, then you will understand that how ForkJoin is implemented in Java. Okay, so mainly we need to, in order to understand the effect of ForkJoinPool, we need to understand the result. this output result output, okay, the result one, okay. But in order to understand the result, we need to execute the program. The program is here. Let me open this program in Eclipse. So if you go to my GitHub account, okay, actually I have the program. I added on my Replit, but this program will not be executed. You cannot execute this program on Replit. You cannot run this program on Replit, but it needs to be executed on command line. So if you go to my GitHub account, then if you search for my repository ForkJoin, okay, ForkJoin parallel processing, this project, okay, if you colon this project, so it has only one program, Fibonacci.java, this program. Let us try to understand how the ForkJoin. So the Fibonacci class, this is the class, and it extends the recursive task method, okay, that is integer, that means it is also generic, it takes the integer type value, okay. And this program actually is written to be executed on command line. So this will be another good example for you to understand how command line programs are executed, okay. So far, in all Java programs, we used these are strings arguments, string type argument within a main method, right? But maybe we did not discuss any program to discuss how these arguments are used. With these programs I have discussed how these arguments are used, okay. So then we provide two integers, one for argument 0, the first argument, and another for argument 1, the second argument. When you run this program, I will be providing these two arguments. The first argument I am using Fibonacci of what number I want to execute. I want to find maybe Fibonacci of 5, Fibonacci of maybe 4th Fibonacci, or 5th Fibonacci, or 10th Fibonacci number, and how many times execution times, how many times I want to execute. Actually, in this program, we want to execute the same program multiple times so that we see the effect of fork parallelization, how the time difference we find. So here at the end of this program, we executed time method, system.time method in nanoseconds. This function calls nano time, that means it gets system time in nanoseconds, okay. So then if we get the start time, system.nanosecond, and if we run time will be what is that called, time took, run time, it will be system.nanosecond minus start time, okay. So this nano time method, it returns the current time it comes to this, when it comes to this this statement. So at this position it will get this. So there will be a time when this statement is being executed, and there will be another time stamp when this statement is being executed, right? So the difference between the time, the current time when this statement executing and the previous statement executing, that is being calculated over here. System.nano time minus start time. Start time was my previous system.nano time. How the difference is being calculated from the time that it takes from executing from this statement to this statement. It will be very few milliseconds. And when it divided by 1 million, right, then we get we get the time in millisecond. Okay, so that is for this, just to get the execution time. And here actually the number, okay, compute method, the compute method it is, and the Fibonacci method actually it is here, and the compute method, you see that this is the actual constructor, Fibonacci constructor over here, and this is the method, the compute method. Within this compute method, we are splitting the Fibonacci numbers. You see that we are calling fork and join method. Okay, and we are calling the compute method also. This call is going to be recursive call. So this, if you try later, maybe, okay, if you try to understand this segment of code, okay, this is a it's called recursive implementation or fork join. So that here is, we are calling the fork method. Here my F1 is my Fibonacci object, okay, and it is calling the fork method. And its fork method, what does it do? It splits a task, right? And then here you see that we are calling we are returning this one. Actually we are executing, we are calling that F1 with join method, and we are computing result over here. So here we know that in order to calculate the Fibonacci number, what do we return? Fibonacci, the sum of the previous two numbers, right? Return Fibonacci of sum of the, in order to get the Fibonacci of nth number, we add the Fibonacci of previous two numbers, right? So if I want to execute the Fibonacci like fifth number, I will add the Fibonacci of fourth number plus Fibonacci of third number, right? If I want to execute the Fibonacci of fourth number, then I will add the Fibonacci of third number plus Fibonacci of second number. That is the technique. Okay, so in addition, instead of implementing this recursively, so we are implementing this here using ForkJoinPool. So there is a little bit difference implementation instead of our traditional recursive implementation. So if you recall the recursive implementation of a Fibonacci number, you will see that this will be returned this plus this, but we are sending this to a ForkJoinPool. Okay, so now let us try if we can understand this. Okay, so here we are, when we run this program, we are taking two arguments, one by the argument 0, this args, okay, and another is for argument 1. So the first argument we will be calculating of Fibonacci of what number, which Fibonacci number, maybe 10th Fibonacci number or 5th Fibonacci number or 5th or 4th Fibonacci number, something like this, and how many times we want to find that. We will see that there is a time variation in every execution. I will tell you the reason later, so why there is a time variation, but let us run this program. So okay, I have okay, so I downloaded the code over here for ForkJoinPool in my workspace. So this is the this program. Actually this is the program. Let me open it and see. So this is the program, actually the same program. Okay, we want to execute this program. Okay, so here actually the Java program, when we execute this, it creates the class file that is run. I'm deleting the class file. Okay, so keep attention over here. How do we execute this program? Actually, what do we need to do? We want to execute this program. Okay, we want to execute this program using on command line. Okay, so I need to go to this location. Okay, if I do right click, then get info, then it says that my program is in this folder. Okay, ForkJoin. So this is cd to that folder. Okay, no, it's not going. Sorry, cd or space ForkJoinPool. Let me see what do I have here. If I give ls command, then I have src folder. So cd src, and if I give ls command, then I have this Fibonacci.java. This is my file. So like 20 years ago, when I learned first time Java program, and I wrote my book on Java programming, at that time we did not have Eclipse or NetBeans. Okay, I wrote all of my programs on just a notepad. Okay, we use notepad to write program, and we use this kind of command tool like DOS command prompt to execute compile program, and then if we get error message, then we fixed it and then recompile it and then rerun it. How do we run this? Get the technology, look at how do we do that. Okay, so I'm in this folder. I need to go to that folder. So I'm in this location. You see that, just give attention everybody please here. When I give, so I want to first, this is my raw program, Java program. I want to first compile it. How do I compile a Java program? I need to call Java compiler, Java. It says Java C compiler. Okay, and then I need to write the name of the file exactly. This is the class file, right? Okay, maybe I copied it and I pasted it. Java Fibonacci.java. And as soon as I press enter, then if my program is okay, if it does not have any error, then it will create a Java Fibonacci.class file. You know that, but when you use Eclipse, you do not realize that. Okay, just keep your eyes over here. As soon as I click, keep your eyes over here and also on this window. Okay, that all happens. Okay, so as soon as I click over here, it creates this one Fibonacci.java class file, right? It just created right now, 722. Okay, let me show it again. So if I delete this, not delete, I'm not going to delete this one. Okay, so then as soon as I compile my program, and then it will create that file. But if there is an error on this file, it will not create. It will show that error message over here. Then I open the file again and fix the error. And nowadays we are lucky that we have Eclipse, right? It shows our error right away, compile time. Okay, so this is the time I got my compiled version of this file, right? Now I need to run it. In order to run, Java, how Java programming language works, it has both compiler and interpreter together, right? We just compile. And now we need to use the interpreter. What is the interpreter? Java. I call the interpreter by Java name, and at this time, actually I will call the bytecode Java folder, but I don't need to write Java.class. Okay, at this point I will provide the two arguments. Remember that in my programs I wanted to provide two arguments, one for argument 0 and argument 1. Okay, one for Fibonacci of which Fibonacci number I want to execute, and how many times I want to execute. The first one, let's say I want to execute the fifth Fibonacci number. And let us think that I want to execute 7 times. I want to find the fifth Fibonacci number 7 times. Okay. So when I run this program, I'm keeping this background so that actually it will not make any change at this time. But if you can see, there will be nothing. So if I run this program, you see. As soon as I click over here, this program executed, and see, let us see our result. So we provided 5 over here, so that we want to Fibonacci of 5, fifth Fibonacci. How many times we want to get? 7 times. Okay, so this is my first run, second run, third run. We have 7th run, 7 run. Okay, so we ran this program 7 times. So what are the Fibonacci numbers? Can anyone please tell me fifth Fibonacci number? Is 0. It is this program starting with 1 0 1 1 2 3. Oh no, it starts from 1 1 1. First Fibonacci number is 1, right? Second Fibonacci number is 1. Then 2. Right? Third Fibonacci number is 1 plus 1 2. Fourth Fibonacci number is 3. 2 plus 1 3, right? And fifth Fibonacci number is 5. Right? 3 plus 2, right? 5. Okay, and the sixth Fibonacci number is 8. Seventh Fibonacci number is 8 plus 5 13. Eighth Fibonacci number is 8 plus 13 21. So let us run this program again and get 8 Fibonacci number. Okay, 7 times. Okay, let us compare the result. So we got 8 Fibonacci number is 21. Okay, and we ran this program 7 times. So now at this point we will see the effect of our code that we wrote for this line. We also calculated the time passed in order to execute this program. So you see that if we see that, give attention over here, then we will understand. The first run would take, it took 11 milliseconds. The same program is second run, it took 1 millisecond, right? And third run it took 1 millisecond, 1.1 millisecond, and fourth run it took 1.04 milliseconds, and fifth run it took 1.17 millisecond, and you see in the 7 millis run it took 8.15 millisecond. Do you see the variation between it took time between this? So can anyone guess why this is there is a variation in time? Any idea? If it is a non-parallel programming, okay, every time it would take same time, almost same time. If you run this program with a recursive method, regular recursive method, every time it would take almost same time. Okay, but here in this program we are using ForkJoinPool. Okay, so but in ForkJoinPool, what is the concept in our ForkJoinPool? We are forking our task into 2 subtasks, right? So in one side, for instance, we are forking our task into some initially 2 subtasks, again then branching, right? Small subtasks. But if there is an imbalance, if there is not a good balance, if there is a good balance, okay, then this will take less time. Okay, in order to get 8 Fibonacci number, if you get one side 7 and one side 1, then one side 1 that will be executed quickly, right? And another side that has 7, that will take more time. So until the 7th side does not finish, it will not start executing the result, right? The concept was that when all of the tasks were completed, then the process start to join the result, right? So, but if there is a good combination of like, for when you're going to get 8 Fibonacci number, if one side has 5 another side has 3, then it will be pretty good balance, right? If one side has 4 another side has 4, one side has 4, okay, then another side, if there is a good balance, then it will take less time. But since this splitting is done randomly, so we don't know yet that how that will be done. So in any run, in a specific run, if it does not have a good split, then it is taking more time. It is taking more time. You see that it took 11 milliseconds and then it took 1 millisecond. Do not misguide it that for the first time it is taking more time, for the second time it is taking less time. Not that. If you run this program again, that we will see that. So it varies. If you run this program again, you will see that it takes different time combination every time, even that it takes less than 1 millisecond over here, but another time it took 6 milliseconds or 11, about 12 milliseconds. So this is the concept, but I hope that you will not get interest over here, but I hope if you get some basic idea about parallel processing from your upcoming assignment and this course, then in future you will be encouraged to take advanced level course on this, like parallel algorithm class, okay, and then parallel processing class, other next classes. Okay, anyone has any question? Okay, in our next lecture we will discuss, so get my code and make some changes and run it again, then you will, especially that if you implement this program, then you can see how to run a program on command line. Okay, and we have only one class we needed to discuss non-linear data structure. Actually, in order to say non-linear data structure, that we discussed previously, linked list, array and linked list. Those are straightforward. Okay, but there is another data structure, that graph and trees. Okay, so there is no straightforward, like not and chain. Data is not sequentially stored. Data is stored like a graph or a tree. Okay. So you will learn more in your data structure course, but our goal is to give you some basic idea. Okay, so we will discuss mainly tree, and there are many kinds of tree. These are tree of reverse order. This data structure tree, a tree, this is root. If there is a tree like this, right, this side is root, but upside down tree. Okay, so this we will discuss binary search tree. Binary search tree is a balanced tree that has branches, equal number of branches on both sides. So if it is a root, 15 is on the root of this tree, then you see this is one side and this is one side, and every side has equal number of branches. Okay, so if there is a tree is luckily this kind of balance, then that is called binary search tree. Binary tree, okay, binary tree mainly. Binary tree, that means 2 branches in each branch, 2, okay. And it is again called binary search tree if all of the elements, left elements is left side, all of the elements in the left side are less than the elements on the right side. Here you see that all of the elements on the left side are less than the elements on the right side. So this is called a binary search tree. Okay, so in our next lecture we will discuss binary search tree. Maybe not implement binary search tree, but at least we will understand what is binary search tree and how to traverse by binary search tree. There are 3 traverse order: in order, pre-order, and post order. Okay, so if you understand this. Then maybe if you want to make your intention to major in game development, then there is the uses in using game development by the research team. Okay, so when you move from one branch to another branch, your object. So we will discuss this in our next lecture, and I hope in our next lecture we will finish everything, and after the Thanksgiving break we will review. Okay, so please do not miss our next lecture. In our next lecture we will finish maybe within an hour. Okay, thank you so much. Anybody has any question? Okay, thank you.